we're going to look at how to solve some basic log equations. Let's look at the first one. We have log base 4 of x plus 2 equals log base 4 of x squared. Notice that the two arguments are must be the same, because this is, if we have log base 4 of one number equals log base 4 of another number, those two numbers will have to be equal to each other. So I can just say x plus 2 is equal to x squared. This is quadratic, so it's x squared minus x minus 2. If I factor that, x minus 2, x plus 1. So x equals 2 or negative 1. Now I have to always check back with log equations to find out, because I'm not allowed to take log of 0 or log of a negative number. So I have to check my answers to see if in the original equation either of those two things happen. So if I put in 2, I'm obviously fine. Log base 4, 4, log base 4, 4. If I put in negative 1, this is still a positive number, and this is still a positive number. So both of those are solutions. So I just have to watch out, plug it back in, and see if there's one or more of the solutions are not possible. Now here I have a single log. When you have log of something equals something, the only way to solve this is to put it into exponential form. So I think about, what's my base? This is a base 10. So I say 10 raised to the negative 2 power equals x minus 5. So once I've written it in exponential form, solving it is a piece of cake. This is 1 over 100, or why don't we say 0.001, 0.001, I'm sorry, 0.01. 0.01 is equal to x minus 5. If I add 5 to both sides, 5.01 equals x. There's my solution. Once again, 5.01 minus 5 is a positive number, so I'm good. And that makes sense too. Log base 10 of 0.01 is what when you do 5.01 minus 5 equals negative 2. That's saying 10 to the negative 2 equals 0.01. Yep, that's 1 over 100. Makes perfect sense. All right, now let's look at these two. Now we have more than one log. If we have more than one log, then we have to be able to combine them. When we add two logs, it means that we multiply their arguments. So I'm going to rewrite this as natural log of 3x times x equals 1, or natural log of 3x squared equals 1. Now that I have it down to one log term, I put it into exponential form. This is the same as log base e of 3x squared equals 1. That's what natural log means. So e to the first equals 3x squared. So that means e divided by 3 equals x squared. So x is equal to plus or minus e divided by 3. Well, if you look back in the original equation, if I put negative e over 3 in here, remember e is the number 2.71. As a matter of fact, we can just do quickly on the calculator what e over 3 is. So on your, in case you didn't know, on your keyboard, if you see the pi button, e is also there. So e divided by 3. If you just use e on the numeric, if you just use e on your alphabet pad, it won't give you the number e. And then I do a control enter to get the decimal form. So there's e, e divided by 3. And if I made that negative, then I'd be taking the log of a negative number. So I can only use positive e over 3 as my answer. Okay, let's take a look at this one. Now I'm subtracting the logs. That means I divide their arguments. So log base 2 of x plus 1 over x equals negative 3. Then I rewrite it in exponential form. 2 to the negative 3 is equal to x plus 1 over x. 2 to the negative 3 is 1 over 2 cubed, which is 1 over 8. So now I can say x times 1 is equal to 8 times x plus 1. So x equals 8 times x plus 1. That's multiplying both sides by x to get rid of the x on this side and bring it over here, then multiplying both sides by 8 to get rid of the 8 on this side and bring it up here. So x equals 8x plus 8. Negative 7x equals 8, subtracting 8x from both sides, so x equals negative 8/7. It looks like if I substitute negative 8/7 in either of these logs, I would not get it would take the log of a negative number. So there is no solution to this problem. Okay, no solution. Now there are some trickier log problems, and particularly log problems that can be written in quadratic form. So if you, I will be making a video about exponential and log functions in quadratic form, so you'll be looking for that for those trickier problems. Oh, one other thing before I end. Sometimes you'll get a problem that may be written like this. Say 2 log of x plus log of 5 plus x is equal to 4. And this could get kind of complicated, but I can't just I can't multiply the logs because of this 2 here. And dividing by 2 is a problem because then I'd have to divide this one by 2, and then I would have some issues. So one thing you can do is you can undo the product property of the rainbow rule and put this back on, and I can say log of x squared plus log of 5 plus x is equal to 4. And then I can go through and I can multiply those exponents and make it into a single log. So I'd have log of the quantity 5x squared plus x cubed equals 4. And I actually don't want to solve that because it turns out that's going to be a nasty thing to solve. So, but that just kind of illustrates the issue. Also, another little tip, if you have log of the square root of x equals 5, for example, this can also be written as log of x to the 1/2. And then the 1/2 can come out front if I want to. Now, you don't necessarily need to do that, but if you need to do that, if that's helpful in a problem to rewrite it that way, you can do that. So then I can multiply both sides by 2 and say log x equals 10. Well, I'm saying then 10 to the 10th equals x. Ooh, that's a big number. So 2 times 5, yeah, it looks like that's all good. 10 to the 10th power equals 10, equals x. So just some other examples of different things that you might encounter when running into log problems.